You're welcome back to my YouTube channel, and in today's video, I'm going to be starting a new thermodynamics series called the gas power cycle. So now let us start with our topic on gas power cycle. First of all, we know that gas power cycles are what form the basis of power plants in which working fluid is a gas. That is, the working fluid is a gas, something like petrol or diesel, or in ideal cases air. So in the gas power cycle, um the gas power cycles here, this cycle includes internal combustion engines, Ericsson cycles, and Stirling cycles, as it is mentioned over here. And these internal combustion engines are the one used in turbines, jet engines, and different type of combustion engines. That is, an internal combustion engines basically is known internal combustion engine basically is known to convert chemical energy. Internal combustion energy is known to convert chemical energy into heat energy, which also converts heat energy into mechanical energy. So it converts chemical energy to heat energy, and this also converts heat energy to mechanical energy. So now that is how an internal combustion engine works. That is to say, if you put a fuel into the engine, it creates its energy. That is, with the effect of your spark plug, it creates it, and then it helps facilitate the mechanical energy of the machine or the engine that we are talking about. So, for example, we are going to take a look at one of the examples of internal combustion energy, and we are going to try to explain internal combustion engines. Internal combustion engines can be divided into yeah, we know a few of them. One of them is the petrol engine, which is known as the Otto engine, and the we have the petrol engine, which was developed by Nicholas A. Otto in 1876, and we also have the diesel engine, which was developed by Randolph Diesel. We also have others that are known as the dual cycles, whereby we are it's using both the auto mechanisms and the mechanisms all together in one. So that is it for auto and this. So internal combustion engine is can be described in this in four strokes. The first strokes, yeah, this is an example of an auto engine. The first stroke, whereby we have, this is when it is at the top dead center. Yeah, this is where the piston is at the top dead center. It is at the lowest point. So at this particular point here, at this particular point, at this particular point here, the piston is at the top dead center, and then fuel is injected into it. That is isentropic heat addition. So when it is added into it, then there is compression of the fluid, there is compression of the gas there. So this is compression. This is compression happening here, and then after the compression, it creates the spark plug creates it. The spark plug creates it there, and we have its addition. So there will be some kind of combustion in this third slide here. There will be some kind of combustion over here. There will be some kind of combustion there. So after that, we also have in this fourth side, which is over here. This one is the last part, whereby the gas comes out after the combustion pushes the piston back. So the entire purpose of this combustion engine is to make sure that this piston is moving in a rotatory motion. And then you can see more about the piston over here, down here. That is, here we see the diagram of our cylinder, our combustion engine here. We have the piston here. This is our piston over here. So we know that that is our piston. Then this is our cylinder wall. Then we have our valve. That is, the valve is what allows the entrance of gas and the and going out of gas. That is isothermal. It's whereby we are adding our petrol and exhaust is coming out. Then we also have the top dead center and the bottom dead center. That is from this to this, which is there the top dead center and the bottom dead center. That is the maximum point whereby the piston will reach here, and the minimum point whereby the piston will reach here. And we also have the clearance volume. The clearance volume is the minimum space that is allowed there. That is the volume, the clearance volume that is allowed there. That is where the entire compression, that is the minimum point of compression. And then there's something known as the compression ratio, which is the maximum volume minus divided by the minimum volume. That is what gives the compression ratio. We also have our spark plug. This is what creates spark. That is, it causes heat addition in, yeah, it causes its addition in the engine. Then we also have our crank mechanism, which is the entire point of, that is our crankshaft and our crankshaft and our connecting rod over here, which is the entire point of our combustion engine, which is to make sure that this is rotating steadily. Thank you very much.